Now we're going to look at Bernoulli trials and the probability of success after 1, 2 or 3 trials. So a Bernoulli trial, or a Bernoulli trial if you prefer, is an experiment with repeated trials. There's 3 important characteristics of Bernoulli trials. Each trial has 2 possible outcomes, success or failure. The probability of success doesn't change from one trial to the next. Each trial is independent of the other trials. Let's look at an example of a Bernoulli trial. A die is rolled repeatedly until a 6 is rolled. What is the probability that this will happen on the first, second or third roll? Well, this is a Bernoulli trial because there are 2 possible outcomes for each trial. You could have success or failure. So you either get a 6 or you don't get a 6. That's all you care about. So 2 possible outcomes. The probability of success doesn't change from one trial to the next. That's true. The probability doesn't change from one roll to the next. And each trial is independent. So the outcome of the first roll has no effect on the outcome of the second or the outcome of the third. So let's go ahead and answer the question. First of all, let's define what success is in this case, and let's figure out the probability of success. So success is getting a 6. Failure is not getting a 6. What's the probability of success? Well, it's 1 out of 6. There's one way of getting a 6 when we roll a dice. 1 out of 6 outcomes. So the probability is 1 out of 6. 1 over 6. Probability of failure. Well, there's 5 ways of failing. So it's 5 out of 6. So let's explore this scenario using a tree diagram. So in the first trial we could have a 6 or we could have failure. Second trial we could have a 6 or failure. Third trial, a 6 or failure. 6 or failure. And so on. Let's put in the probabilities at each stage as well. So the chances of getting a 6 on the first roll of the dice is 1 over 6. Chance of failing is 5 over 6. 1 over 6, 5 over 6, and so on. Just fill the rest in now. So we were asked, what's the probability of success on the first roll? That's the same as saying, what's the probability of getting a 6 straight away? So that would be going down this branch of the tree. So the probability is 1 over 6. Second part is, what's the probability of success on the second roll? Well, for that to happen, we must fail on the first roll. So it's like saying, what's the probability of failure followed by a 6? That means we must go down this branch of the tree and then along this branch. So that's 5 over 6 and 1 over 6. And we multiply them because we want this and we want that. So when there's and involved, we multiply. So 5 over 6 by 1 over 6 is 5 over 36. That's the probability of success after 2 rolls, the second trial. Now for part 3, the probability of success on the third roll. Well, for that to happen, it means we must have failure, failure, and then a 6. Which means we must follow this branch, then this branch, and finally this branch. So 2 failures followed by a success. So the probability of that is 5/6 by 5/6 by 1/6, which is 25 over 216. Let's look at another example. A card is selected and replaced in a standard deck until a face card is selected. What is the probability that this will happen on the first or second draw? So first of all, success is to draw a face card. And the probability of success, well, there are 12 face cards in a deck of 52. So simplifying that, that's 3 over 13. is the probability of success. Failure is to draw any other card. So the probability of failure, well, there are 40 non-face cards in the pack. That's 10 over 13. So now we can draw a tree diagram to represent the trials. So we have a face card, or we have failure. So let's just say face or fail. And again, face or fail. Face or fail. Well, let's put in the individual probabilities. So 3 out of 13, 10 out of 13, 3 out of 13, 10 out of 13, and so on. So the probability of getting a face card after one draw is 3 over 13. Now we need to know what's the probability of getting a face card after the second draw. Well, you might say it's 3 out of 13 as well, because the probability doesn't change from one trial to the next. It is true to say that if you take the second trial in isolation, that the probability of drawing a face card is 3 over 13. But in this scenario, we're saying that a card is selected and replaced until a face card is selected. So in this experiment, for a face card to be drawn in the second trial specifically, two things must happen. We must have failure in the first trial, and then a face card. So we're not really asking what is the probability of getting a face card in a single draw. We're actually asking what is the probability of this path being followed. First failure, and then success. So the probability is 10 over 13 multiplied by 3 over 13, which is 30 over 169. Let's look at another example. The probability of rain on any day is 1 in 4, a quarter. What is the probability that the next rain will fall on day 1, day 2, or day 3? First of all, let's define what success is. In this case, success is rain. That may not sound intuitive, but in this case, success is rain. And failure is no rain. The probability of success in this case is a quarter. And the probability of failure is 3/4. If we have two events and one of them must happen, then their total probability must add up to 1. So if the probability of rain is a quarter, then the probability of failure is 3/4. Now what is the probability the next rain will fall on day 1, day 2, or day 3? We could explore this using a tree diagram, but now that we're a bit more comfortable with it, we don't really need to do that. Let's look at part 1. What's the probability it'll happen on day 1? So that means, what's the probability that we get rain straight away on day 1? Well, that's just simply a quarter. Part 2, what's the probability that the next rain will fall on day 2? So that really means the probability of failure followed by rain, if it's going to be the next rain falling on day 2. So that's the probability of failure, 3/4, multiplied by the probability of rain, which is a quarter. So that's 3/16. So that's the probability of the next rain falling on day 2. Part 3, what's the probability that we don't get rain until day 3? Well, that means the probability of failure, failure, and then rain, which is 3/4 by 3/4 by a quarter, which is 9 over 64. So it's not essential to use the tree diagram once you get comfortable with the idea. So that was Bernoulli Trials and the idea of success after 1, 2, or 3 trials. Thanks for watching. Talk to you in the next lesson.